Hello, and welcome to a screencast about functions as a process. Some important notation here. So this says if we name a given function f and call the collection of possible inputs to f the set A, and the corresponding collection of potential outputs B, we say f is a function from A to B. And then we use this particular notation. So f colon and then A to B with an arrow. When a particular input value to f, say t, produces a corresponding output z, we write, here's another important notation, function notation, f of t equals z, and read it as actually I just did. We often call t the independent variable and z the dependent variable, since z is a function of t. If you want to interpret these values, then that's going to be an important part of our class, is going to be interpreting things. So in a previous video, you saw that height can be thought of as a function of time. If you are given a function where the height h is measured in feet at time t in seconds, as h equals f of t equals negative 16t squared plus 8t plus 4, determine and interpret the following. So determining, that's going to be some number crunching. You can do that in Desmos, you can do that on your calculator, whatever floats your boat. But interpreting is definitely going to be where we really want to work at. Okay, so f of a half. So because this half is inside the parentheses, that means that's our input value. So whenever we see a t appear in our function, we're going to replace that with a half. So negative 16 times a half squared plus 8 times a half plus 4. So that gives us negative 4 plus 4 plus 4, which gives us 4. All right, so again, my input is the time in seconds. So at a half a second, my output is the height. So we can say the object's height is 4 feet. All right, how about f of 1? So again, 1 is inside those parentheses, so let's go ahead and crunch that out. So negative 16 times 1 squared plus 8 times 1 plus 4. So that gives us negative 16 plus 8 plus 4, which I believe is negative 4. Okay, so 1 is our input, negative 4 is our output. Can you have a negative height? Yeah, no, this one doesn't make any sense. Okay, so does not make sense. Or however you want to phrase that. But remember, so mathematically we can totally compute f of 1, but realistically, does it have an interpretation? And the answer is no. Okay, let's look at f of negative 1. So again, negative 1 is my input. I'm going to go ahead and crunch that out. So negative 16 times negative 1 squared, 8 times negative 1 plus 4. So that gives me negative 16 minus 8 minus, plus 4. Then that gives me, I believe, a negative 20. So negative 1 is my input. And negative 20 is my output. Okay, this is just getting worse. So can I go back in time? No. So again, this does not make sense. And I wanted to include these two particular examples, not to confuse you or anything, but just to show you, like sometimes when we live in math land, yeah, things totally make sense, but when we actually get to reality, they don't. So you want to always be on your toes, paying attention for that stuff. Okay, one last part here about notation then. And this one says let f go from the set A to the set B, where A and B are each collections of real numbers. So the graph of f is a collection of all ordered pairs x, y, such that satisfy y equals f of x. Okay, so again, input is x, output is y. So given the graph below, answer the following questions. So find f of 0. Okay, so 0 is my input. Beautiful, so that means I need to get my output. Or we could say that 0 is my x, so x equals 0. What is y? So that's another question you can ask yourself. All right, so if I go over here at x equals 0, I go up to see where it hits my graph at, and it looks like it's 3. So f of 0 equals 3, or I could also write this as a point, 0, comma 3. Same thing for f of 2. So this is saying that x equals 2, y equals what? Okay. And, oh, we've looked at this graph before. So at 2, we've got this hole, which we can ignore. But remember, it's the point up here that matters. So f of 2 is also 3, or we could write this as the point 2, 3. And then finally, a different question, for what values of x is or are f of x equal to 3? Apparently 3 is the theme for today. So this one's a different question because you notice that the 3 is now on the other side of the parentheses. So that means that's our y value. So y is 3, x is question mark. So let me pull up a different color here. If I go across at y equals 3, how many x values do I get? And in this case, I get 2. They're ones we've already looked at. So x is going to be 0 and x is going to be 2. All right, thank you for watching.